In this video, you will learn to use ratio tables and how to complete missing parts of a ratio table. Now the question is, what is a ratio table? Well, a definition is it's a method for organizing equivalent ratios. So you're going to put the equivalent ratios in a table format. So how it works is we can extend a pattern between terms by multiplying or dividing each term by a constant. So what does that look like? So here's our first example. This is dealing with money earned and the number of hours worked. So notice we have this first column right here. This first column says that individual worked for 1 hour and earned $8. So the ratio would be 8 to 1 or 1 to 8, depending on which way you look at it. And we want to extend this ratio to determine different values for different hours. All right, so what we can do is we can take the 8 and the 1 and multiply both numbers by 2 or by 3 or by 4, etc. And we see here that's what we have in the table. 8 times 2 would be 16, and 1 times 2 is 2. So if we did 8 times 3, that would give you 24 for this column right here. And then 8 times the 1 for hours worked, 3 times 1 for hours worked would be 3. And we see the pattern continues. We do 8 times 4 and 1 times 4, 8 times 5 and 1 times 5, 8 times 6, 1 times 6, and etc. So what this does for us is we can very quickly look at the table and determine the money earned for the number of hours worked, or vice versa. We could figure out how many hours you have to work to earn a certain amount of money. So if I were to ask you how many hours are needed to work to earn $72, you can look right here at the table and we see money earned is $72, and to make that happen you must work 9 hours. So we can use the different columns in this table to answer questions like that. Now we don't need to multiply the numbers by some other number. We could also divide. So for example 2, we see here that we are told in column 1 that $16 would have 64 quarters. So 64 quarters make up $16. So if you have information like that, what we wanted, or what we could do is, if we want, we could divide these numbers by different numbers. So for example, we could divide 64 and 16 by 2. That would give you 32 quarters and $8. So $8 would equal 32 quarters. Or we could divide by a different number. We could divide by 4, as we see here. 64 divided by 4 is 16, and then 16 divided by 4 would be 4. And again, we can continue with different numbers. So we can do divide by 8 or divide by 16, and we get these different values. So again, for example, if we wanted to determine, let's say, how many dollars are required to make 4 quarters, or 4 quarters would equal how many dollars. So if you didn't know that, you could look here at the table and realize that 4 quarters would equal $1. Okay, so you can look at the table to determine that. All right, so we can divide or multiply the first column by any number to carry the pattern on. Now we can use this to complete ratio tables if you have different parts that are missing. All right, so here we have meters and kilometers. So looking at this first column, we know that 1 kilometer is 1,000 meters. And you have to use that relationship to answer the missing parts of the table. All right, so notice on the bottom, there's a pattern. We're going by ones, 1, 2, 3. This would be 4, then 5, 6, 7. That's kind of hard to see with the blue ink. So that would be 4 and 7. And then on the top, if we notice the pattern on the top, left to right, we have 1,000. This would be 2,000, 3,000, 4,000, 5,000, 6,000, and 7,000. So different ways to think through this actually. So we see left to right there's a pattern on the top and the bottom, but we sometimes might need to look again at the vertical. So if you look at the vertical, for example, we take this first column, 1 and 1,000. We realize to get from 1 to 2, we had to multiply by 2, right? 1 times 2 is 2. Do the same thing on the top. 1,000 times 2 would give you 2,000 for that second column. All right, so we can think of it that way. And then for this fourth column right here, if you got to figure out the number 4, okay, we can look and realize that 1,000, this first column, times 4 would give you 4,000. So we can take the 1 times 4 to get 4 on the bottom over here. All right, so there's patterns in different ways, vertically and horizontally, that you can use to fill in this table. Here's another example where we have quarts and gallons. So again, our objective is to fill in this table. Well, we're missing the first column, so this one's a little trickier. We want to look at a column that has both quarts and gallons to figure out what is the relationship. So looking here at the second column, we see to get from 2 to 8, that relationship is 2 times 4 to get 8. So the pattern vertically is timesing by 4. So we can realize that pattern would hold for the other parts as well. 1 times 4 would give you 4 for the number of quarts. So if you have 1 gallon, that's 4 quarts. So keeping that pattern going, you could multiply the 4 by 4 to get 16. 8 times 4 would be 32. We already got that. And then something times 4 is 64. That's going to be 16. 16 times 4 is 64. So there's patterns vertically. There's also patterns horizontally. Notice on the bottom, the pattern is times by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Same pattern on the top. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So again, there's different patterns, both vertically and horizontally, that we can use to think through the different missing parts of the table. Here is a third example where we have feet and inches. So if you don't know the conversion factor, we can look at this table that we have created. So in the first column, we were told that 10 feet is 120 inches. So the pattern vertically is we do 10 times 12 to get 120. So what times 12 gives you 60? It's going to be 5. And then 2.5 times 12 gives you this number right here. So 2.5 times that by 12. If you multiply that, you're going to get 10, carry the 1. 2 times 2 plus 1 is 5. 0, 1 times 5 is 5. 1 times 2 is 2. Add them together and you get 300. We move the decimal point over one place to get 30. So this would be 30 for that part. So again, the pattern is multiplying by 12. So 1 times 12 will give you 12 right here. And then 0.5 times 12, or half of 12, would be 6. All right, so again, we can use a pattern vertically, or we can look horizontally sometimes to determine the pattern. So now that we know how to use the ratio table, how to fill in missing parts, we could use ratio table to solve word problems as well. All right, so here, this is actual information. So this is true statistics. And here we're told that an average person burns approximately 100 calories for each mile that is run. So that is actually a true fact. And the question is, how many calories are burned in a 5-mile run and then in a 26.2-mile run, which would be a marathon. All right, so what we can do is we can create a table, so a ratio table. So we can use the information given that 100 calories are burned for each mile. So 100 calories are burned for 1 mile. So that is the ratio, 100 calories to 1 mile. So if you create a table, we can create one row with calories and then one row with miles. So we were told that 1 mile is 100 calories. So you plug in that data into the table. So we can create a table, plug in numbers. So if 1 mile is 100 calories, then 2 miles would be 200 calories, 3 miles, 300 calories, 4 miles, 400 calories, 5 miles is 500 calories, which is the first part of the question. How many calories are burned in a 5-mile run? So that answer would be 500 calories. All right, so we notice the pattern vertically, right? We do 1 times 100, 2 times 100, 3 times 100. Whatever's on the bottom, you multiply by 100. So if you have 26.2 miles, you have to multiply that by 100 to get this that cell right there. So what is 26.2 times 100? Well, the decimal point moves over 2 places, 1, 2, to get 2,620 calories. So a person that runs a marathon burns, on average, about 2,620 calories. All right, we concluded that from this table. And keep in mind, tables are not necessary to answer different questions like this, but it can be helpful to kind of organize the data and to kind of tell maybe a little more quickly sometimes for multiple values. All right, so that's one example. And then here's one more where we can use ratio tables to solve word problems. All right, so this one, we're told that 3 cups of water needs to be added to 4 cups of pancake mix. And the question is, how many cups of water are needed for 1 cup of mix and for 6 cups of mix? So to begin, we can use the given information. 3 cups of water goes with 4 cups of pancake mix. So we have water and we have pancake mix. So in our table that we create, we can have 1 row with water and 1 row with pancake mix. And we're told that 3 cups of water is needed for 4 cups of mix. So we can plug in a 3 and a 4 into the table. Okay, so from here, we can use this information to figure out how many cups are needed for 1 cup of mix, and then how many cups of water is needed for 6 cups of mix. All right, so different ways you can think through this. There's not one correct way to fill in this table, but one way is we can maybe divide this mix by 2. If we divide by 2, that gives you 2 for like 2 cups of mix down here in the bottom, and then divide the top by 2 to get 1.5, 1.5. If we do this again, if we do 2 divided by 2, that gives us 1 for the cups of mix, and 1.5 divided by 2 is 0.75. So if you can't do that in your head, you could work that out. 1.5 divided by 2. 2 goes into 15 7 times. 7 times 2 is 14. Subtract, we have 1. Add a 0, bring it down, and repeat. 2 goes into 10 5 times. 5 times 2 is 10. Subtract, and we have no remainder. So if you can't do that in your head, you can use a calculator or divide that out. So we have answered actually the first part of the question. How many cups of water are needed for 1 cup of mix? Well, 1 cup of mix requires 0.75 cups of water, which would be 3/4 of a cup. Now the last part of the question says how much water is needed for 6 cups of mix. So one other technique we can use that we've not explained yet is we can use given information in the table to maybe add if needed to get the numbers we want. So we could try to figure out the relationship vertically or horizontally, but notice the number 6. If we put 6 cups of mix, okay, that doesn't fit very well with the numbers we have here. Okay, right, because 4 times 2 is not going to be 6. We have to multiply by a fraction. But here's a quick technique we can use. So if we add 4 cups of mix plus 2 cups of mix, we add those together, that equals 6 cups of mix over here, right? So what we can do is to figure out the water, we can also add the 2 water numbers. So if we add the 3 cups of water plus 1.5 cups of water, that correspond with the 4 and the 2 for the mix, 3 plus 1.5 would give you 4.5 for the cups of water. So that's a technique that could be helpful if you have numbers that do not work very easily with the numbers that are given originally. All right, and that concludes our lesson for today. We will see you next time.